Once you graph it, check with Desmos. Make sure you all the points matching up. Yep. Positive and more interesting. Winston, can you come this weekend?
This weekend? No, I'm going to a tournament.
What?
Jiu-jitsu.
I need somebody.
Jiu-jitsu, I gotta go. I paid.
Huh?
I paid to go.
I gotta recruit 2 other people.
Over fees. There you go, bro. Good time for this.
Yes.
You know where like your point for CSV.
CSC is similar to sine graph. So you're gonna have to graph sine graph first. And sine, if you don't remember, sine start at a midline. Positive sign is midline going up. Negative sign is midline going down. So this one's a negative cosecant. So you're gonna start at graph cosecant first, which is sine first and then cosecant.
Wait, so sine starts at the midline?
Yeah, sine. Write it down. Sine start at midline. Is it positive? It's going up. Is negative? It's going down. Cosine start at a peak if it's a positive, or cosine start at a trough if it's a negative.
So what about CSE?
CSC is same. You have to graph sine first before you graph cosecant. So you have to graph sine correctly before you graph cosecant. But every time the sine graph heads to the midline, it's going to create asymptote, just like we talked about before. Once you do that, you're gonna do inverted parabola. But Miranda should be able to help you when you get there. London, would you want to do a math competition
Maybe.
this weekend?
Take my place, bro.
Because Winston cannot go. Winston kind of bailed on me twice.
Twice. I never committed to this.
No, the first time you were like supposed to show up, but
Well, no, I know that. That one I took. That one I knew because
he overslept. Yeah.
I forgot to put my list.
Castanea, you'll show up, right? Lyman High School.
Where is that?
You got the
Huh?
Where is that high school?
Altamont.
yeah,
Oh, you should do it.
Lyndon, let me know if you can do it. I need one more person. Alex?
Do not trust that man.
I don't. Sorry, Alex. Your test scores.
I'm not bad at math.
No, you're good. You're good. I'm not saying you're bad, but you're missing something.
It's hard for me to understand why we're doing it.
Huh?
Like, I can do it if I understand why. I did really good on the like the wheel stuff.
And like the RPM, I can't understand the cosine.
I need you to understand cosine stuff. Another person would be candidate would be either Anna or Apple. Anna, you want to do math competition or no? Saturday in the morning.
I have another competition.
Color guard? Okay.
Yeah, I have a question.
Maybe next year. Yes.
I have a question about this. How far do it like? How do I know how far apart like the peaks and troughs?
Depends on the amplitude.
Also, like if the amplitude is 4, they're gonna be like 4 spaces.
No, it's gonna be 8 space apart because it's go up 4, go back down 4. But the peak and trough is inverted, so you are gonna have 8 space apart.
No, I'm not saying like up and down, like left and right.
Well, go ahead and grab it and check the decimals. Okay, what else I can ask? Bao, you like math? No? No, she don't like math.
Huh? You go?
Clutch up this time.
Sophia came and clutch up on my test.
Bro, I know I did good.
Oh, yes,
This time. Don't give me my paper to check.
I'm gonna beat you up.
Apple made some mistake.
I take Apple more than you right now.
What do you mean for math competition?
Yeah. Apple, you wanna do math competition? No?
Her only hope is the HSCs are gonna do better than if you don't.
I can't.
I had to put up with Sophia. I'll take Diego. All right. What we're gonna do, we're gonna start graphing. Let me know if you have any questions, because now is a good time to ask questions. What we're gonna do is factor out 3 over 2. So it's gonna be 3 over 2. But if you factor out 3 over 2, that means you divide it by 3 over 2. Does that make sense? So that's equal to pi over 4 times 2 over 3, which is what? 2 pi over 12, which is equal to pi over 6. So it's going to be x plus pi over 6 minus 1. Questions? Amplitude for cosecant is none. So please don't put that there was cosecant. But for sine is 4. So I can say why is it so the sine is gonna be 4. So you have amplitude. You also have a period. Period is equal to 2 pi over 3 over 2. So it'd be 2 pi times what? 2 over 3. So that's equal to 4 pi over 3. Is that okay?
Yeah.
So quarter periods, that's going to tell me the major change. So that's going to be pi over 3. But it's moving right or left? Left. So left, pi over 6. Now, I'd rather keep this the same denominator. So this and this, I want to keep the same denominator. So I'm going to say it's 2 pi over 6. So that way I can use the same scale without have issues. Does that make sense? So what I'm going to do is I'm going to draw it out. And here we're going to say that's left pi over 6. And each thing is 2 pi over 6. So here is pi over 6 here. And 3 pi over 6. And 5 pi over 6. And 7 pi over 6. And then the other backward, this is going to give you 4 spaces. It's going to give you negative 3 pi over 6. And negative 5 pi over 6. Is that okay?
Yeah.
So now I start with this line. I start with this line here. And I start a midline. Sorry, midline's where? Negative 1. So I'm going to use negative 1 is right here. I'm going to use that's negative 1. So negative 1 is right here. So I'm going to have this coordinate right here. I'm going to start because sine start at a midline. Yes.
What is the line that's vertical? What is that?
It's at this is at negative 1. So I use 2 spaces negative 1. Because
Oh, why is the
vertical?
Yeah.
What do you mean vertical? You're talking about this line?
Yeah.
This line is I'm going left. So I know where I start. I can erase this.
Oh, okay, okay.
I can erase this. I just want to start knowing where to start.
Okay.
So I know where to start here. I know like start from here. Is that okay?
Yeah.
Now I'm gonna go from this point and then go down or go up. How many units?
4.
So 1, 2, 3, 4, and 5. So it's gonna be right here. So it's gonna go down like this. And it's gonna go up. And it's gonna go up 4 units, so it's gonna be 3 units to the top. 1, 2, 3. So it's gonna be here.
Why is it not that far?
Because from negative 1 to go up 4 is gonna be 3.
No, but like, why is the dot like 1 pi over 6 instead of like the actual line? Do you get what I'm saying?
No, each one movement is gonna be exactly a quarter period. Because from pi over 6 to 2 pi, you had to move 2 pi over 6. So you had to move 1 and 2 to get to the next point. And here's the next point, here's the next point, here's the next point. Now I'm gonna go up to here. So this point is right here. And this point's right here. And then now I'm gonna create an asymptote. So let's create an asymptote. Every time you hit midline, it's gonna have an asymptote. Every time you midline, it's an asymptote. Every time you midline, asymptote. So the graph of this graph is gonna look like this. This is the actual graph. And now I can check the decimals, make sure I'm okay. How many of you guys understand what's going on? Raise your hand. How many of you guys have no clue what I just did? Oh boy. Okay, so start with, huh? Because each quarter period is 2 pi over 6. So I'm moving 2 pi over 6. So each 2 spaces is pi over 6. So I'm moving 4 spaces. Yes, Cindy.
Wouldn't it be like on the like at the top? Wouldn't it be at 4, not 3?
It will be at 3 because you found negative 1. Negative 1 go up 4, it's gonna be 3, not 4. You go like in the basement, like go up to 4th floor, it's gonna go to 3rd floor. It's not gonna go to 4th floor. Yes, Isaac?
Why is it crossing the midline negative 5 over 6?
Because they say it's left pi over 6. Because here is positive pi over 6. That means you start at the left side of the pi over 6. Because it's called horizontal translation. Yes,
Why do you start at pi over 6?
because it has a horizontal translation of pi over 6 right here. So it's a graph. Let's say if you have x minus 2 like this, right? The graph is going to go right 2. But it's a plus 2, it's going to go left 2. It's opposite inside the parentheses. Does that make sense?
Honestly, like, I thought we started out like on the y.
No, you don't start y-axis. It really depends on here. It's x plus something. X plus something is moved left how many units? It doesn't have to start y-axis. Start at the translations. You have a horizontal translation. You shift the whole graph left. It's actually pi over 6. Okay, any other questions? Sophia, you better ask questions. Do you understand them? Okay, that sounds like no.
Why is your graph just like so high? It's so skinny.
Because I want to make sure that this is the actual graph. This is a fake graph. This is a sine graph. I use a sine graph to go graph the cosecant graph.
Where's the cosecant graph?
Cosecant graph is this part. This part is cosecant. I can pretty much erase all this graph. That if you type in a decimal, it's gonna show up like this. It's gonna be like this. Okay, so now you understand how everything is. Now I'm gonna show you how to graph tangent and cotangent graph. Tangent is interesting because this will be tangent graph. So you have to know tangent graph here. Now, first of all, you have to know when tangent is asymptote. When is tangent asymptote? Tangent of what value is equal to undefined? Tangent of what value equal to undefined?
No, never mind.
Yes, Amelia?
No. Pi over 2.
Pi over 2.
I don't guess that.
It is pi over 2. You're right about the coordinate. 0, 1 is either pi over 2. Because 0, 1, you have 1 over 0. Because y over x. So it's going to be undefined. So I here is also undefined on that side too. At negative pi over 2. Because they have 1 on each side. Now tangent of 0 is going to be what? Yes.
Pi and
I said tangent of 0. What is tangent of 0?
Pi over 3.
No. What is tangent of 0?
2 pi.
No, you are just reading out numbers. What's tangent of 0? Think. 0. Thank you. Good. 0.
I said it because he said it, so he gets the credit.
Oh, okay.
Wait,
Appreciate you.
wait,
Yes.
I don't get the. Wait, where's your?
Okay, think about what the tangent of pi over 2. Tangent of pi over 2 is equal to sine of pi over 2 over cosine of pi over 2. What is sine of pi over 2? 1. Cosine of pi over 2, 0. It's undefined. That's why you cannot say none on your test. It's actually undefined. Remember, that's why I can then give you credit. Because you say none, but it's actually undefined. So undefined is going to create asymptote. So same thing as tangent of negative pi over 2. That's also undefined as well. So that's asymptote. Now what's this point here? Between 0 to pi over 2. What is that?
Oh, like 45 degrees.
Which is pi over what? Pi over 4. Good. So what's tangent of pi over 4?
1.
Good. That was good. That was good. Really, really good. And what's the tangent of negative pi over 4? Negative 1. So, but the problem is, there is more, if you go toward more outer, let's just say go into, let's just say pi over 6. Or let's say go over to pi over 3. If I go to pi over 3, is it have a higher y value and lower x value. That make the value, so imagine you have a value here. This one gets bigger, and this number gets smaller. What will happen to this actual number after you divide? Well, think about it. It's like 5 divided by 0.5. It's going to be like 10, right? Because one value is getting bigger on the top, one value getting smaller on the bottom. So this graph is going to go like this. It's toward the asymptote. So it's going to look like this. So the way to think about tangent graph is this. You start at center on both ends. At exactly half period, you're going to have a asymptote. So like if you get near me, I'm going to punch you. So this is my asymptote right here.
I have to get those points though. I know pi over 4, but how'd you get like
Pi over 2? Pi over 2, we know it's not defined.
Small dots.
What little dot? Oh, this is a 1, this is a -1. This is a 1, this is a -1.
Then
So
how'd you
I,
get that?
because tangent to pi over 4, you told me. I
Oh,
didn't.
I did.
You told me tangent to pi over 4 is a 1. I just plug in 1. I'm going by what you say.
So it's undefined, like always do.
Yeah, undefined is usually there unless you have a stretch and compress. So unless you have stretch and compress, but now it's gonna be just going left side, it's gonna be pi over 2. Going right side, it's gonna be pi over 2. That's gonna be an asymptote. Yes, Saphir?
How is it tangent of pi 0?
Huh?
Isn't tangent of pi 0?
Tangent of pi is tangent of pi is 0, but you remember they can go multiple periods. So tangent of pi is right here. This is pi over 2, and pi over 2. This is gonna be pi. So this is a pi over 2. This is a 3 pi over 4. This is a 5 pi over 4, and this is 3 pi over 2. So that's gonna create another asymptote. And that's just another graph. It repeats itself. So they have a period as well, except their period for tangent. So period for tangent, you might want to write it down. For tangent is equal to pi. Okay.
Is it always
Huh?
is it always
No, depends on, it's a so you know how like a period for is 2 pi over b, right? 2 pi over b. So for sine and cosine. Okay, so this one is actually pi over b. So depending on the b value. So the b value here is 1, so therefore it's gonna be pi over 1, so it's pi. So that means if I go from center, this is my head, this is gonna be the center of the tangent graph. Then I'm gonna go like this. If I'm doing this, I'm gonna do like this. This is pretty much it. And the other one is asymptote. Asymptote is based on the half period of the tangent. So if you stretch half period here, stretch half period here, you're gonna have an asymptote. Yes, Diego. Ah, see, I'm telling you, Diego will be a good on math team. Yes, he's gonna be slightly opposite, but there's a thing that's slightly different because cotangent is gonna have start with the asymptote. So we're gonna talk about cotangent graph. So cotangent graph, what's cotangent of 0? No, you're doing good. That you will actually lead to the next question. What? Cotangent of 0 is pi over 2? No. Thank you. Cotangent of pi over 2 is undefined. Why? Because at 0, you're going to have 1, 0. And cotangent is what? 1 over 0. So it's going to be asymptote. So you start with the asymptote. Your cotangent is going to be pi. So this is pi over 4. This is a pi over 2. This is 3 pi over 4. This is a pi. So it's going to create another asymptote here. Now, cotangent behave exactly what Diego says. It's opposite. except their center value is not at 0. Their center value is at pi over 2 and going this way and going the other way. I always thought Diego's one smart person, but he's really smart. He just needed pulled together. -10 looks like this, but -10 is gonna look like this. But it's on the same restriction. But this is the cotangent. Cotangent is gonna start at 0 to pi. So the way to think about this, like I will write down some hidden rules for you. So sine, right? Sine, you start at a midline. And it's go up is a positive. It's go down is negative, right? It's a cosine. You start at positive is a peak. If it's a negative is trough. Tangent is different. Tangent start with a center. Start with center. What do you mean start with center? It's gonna have that graph going half period back. Okay? Cotangent is actually easier. Cotangent is surprisingly easier. Cotangent start with the asymptote. So if you write this all down, it kind of give you a hint what it's supposed to look like. Cotangent usually start with asymptote. If you start your first value, it's gonna be asymptote. Now you coming back, you're sleeping. I thought you were closing your eyes. Yes.
I have 2 questions.
Sure.
Where did you get your points from again?
Where do I get what point?
3 points.
Oh, for those 3 points? Think about cotangent of 0, it's going to be undefined. Cotangent of pi over 4 is same thing as tangent of pi over 4. It's
Say that again, please.
okay. I'm going to write down for you. Cotangent of 0 is going to be undefined. Cotangent of pi over 4 is equal to 1. Cotangent of pi over 2 is equal to 0. Cotangent of 3 pi over 2. I get it from unit circle. I didn't get it from anywhere. This is -1. So you get those 3 points here. So they total have 5 points as well. They have 2 points asymptote and 3 points right in between.
Thanks, that makes sense.
You're welcome.
Wait,
Sure.
what did you put for tan? It starts with what?
Tangent start with a center. It's the center of that weird funky graph.
So 0, 0.
Yeah, usually start at 0, 0, and it's gonna have that funky graph right in the center. So on the left side, gonna go this. On the right side, it's gonna go one side. Okay, so now with that being said, I can also graph something a little bit different. That says tangent of 2x. Well, now b is 2, right? So there is no amplitude. Amplitude is none, right? Amplitude is none, but period is what? It's not 2 pi over b anymore. It's 2 pi over 2. Yeah, it's pi over 2, sorry. It's not 2 pi over 2, so it's pi over 2. Why? Because for sine and cosine, it's 2 pi over 2, 2 pi over b. For tangent and cotangent, is a pi over b. So that's the only thing different. So pi over b is pi over 2. Got it? So that means tangent of 2x is going to start with a pi over 2, but it starts at center, right? So I know that I can only stretch half periods. So half period is going to be pi over 4 here. And this is pi over 4. Because only way that's going to give you is that's the whole period. But you start at center. So you start graphing like this, and you start like this, and you're going to be like this. And there's asymptote. You start with that, you graph an asymptote, everything's within. So you're going to start here, here, here. And that's going to be asymptote. And that's it. You graph 2 periods. Yes?
Why is it pi over 4 not pi over 8? Is it the next quarter period?
Yeah, so is pi over 2 is the whole period, right? Now I'm going to think about, I'm in the center. In the center, going to the end, it's going half period, right? From here to go to half period, right? It's kind of like I'm doing cheerleading. I don't know what I'm doing. So here to here is half period, here to here is half period. So that means half of pi over 2 is going to be pi over 4. So I'm going to stretch pi over 4 on this direction and pi over 4 on this direction. And that's going to give you a graphing of this.
Can you put 5 over 2 on the other side? How it's
Which side?
so it's on the I just write it.
Pi over 2? Well, pi over 2 is right here. Like here. And this is a negative pi over 2. So even though this is 2, I just shrinking. My thing is horizontally compressed. So like both sides have a wall, they kind of shrink into halfway.
How did you notice that?
I know because I figure out what is the period. Period is a pi over 2, but period is from asymptote to asymptote. So therefore, from asymptote to asymptote, I'm already center of the asymptote. So that means each side I'm gonna go with pi over 4, and this side is gonna go pi over 4 because pi over 4 plus pi over 4 equal to pi over 2.
Do we always start with the quarter period?
You can think about quarter period. I did here is quarter period. This is actually exactly a pi over 8 here, and this is negative pi over 8. So they all technically have a quarter period, but it's much easier to figure out half period for tangent and cotangent. Because if you figure out half period, you figure out one of those 3 points. Either they are asymptote, or they are the center, or they are the asymptote. I'm sorry, I'm maybe talking a bit too fast because if you don't understand, please let me know. But the best thing is just graph it and to check on decimal, see if you do it correctly. Graph those asymptote in there to see if they align. There's no other way. The problem is most of you guys don't want to try something. Like I told Sophia to graph, he grabbed all graph in a one graph. No, that's not good. You need to graph all in different graph, and you're gonna check on decimals. The problem with Sophia, he has his bad listening skills.
You already said you can't graph it in all one graph.
No, I told you to put on separate graph.
Yeah, both sides.
Everybody else put it on separate graph. How come you're the only one put it in same graph? Where did I get my asymptote? That's a good question. I start with center, right? If I switch, imagine you stretch your left arm out. This is the furthest you can reach. That's your asymptote. You cannot pass anything more than that. So that's half of your periods. And this is half of your period. So you go in half here and half here. This is your whole periods. So because the whole period is a pi over 2, so that means from here to here has to be pi over 4. And from here to here has to be pi over 4. So pi over 4 plus pi over 4 equal to pi over 2. So if I were to say, hey, tangent of 3 over 2x, what do you think is going to happen? So let's graph this one, tangent of 3 over 2x. Now cotangent start with asymptote. I feel like cotangent is slightly easier because you start with asymptote, you end with another period. So it's really nice. But just graph this way differently. You guys just need to try, graph, get it wrong. That's okay, fix it. And it's like you're training AI. You have a pre-learning, you have post-learning. So the way you think about things is you start by getting all the inferences, getting all the things, and entering your data bank, which is your brain. And then you go process, okay, which part I did right, which part I did wrong. And that's how you can become better and better. It's not going to be directly once fits, but most of you guys just want to get it once and get it right. It's not likely to get it once and get it right unless you're really smart. And if you're really smart, then you can do it once and do it right. But most of us, including myself, is not really smart. Like those two kids in back, they are smart. Like I'm not. They're the best in the BC. So, well, they're not even BC. They in Calc 3. Oh, they finished Calc 3. Sorry. He's going to UF. He's not. He's not yet. No.
You have to
Huh?
substitute also.
You almost what?
Homeless right now.
You're homeless right now. Yeah. He's the smartest dumb person in the world. Huh? Really? He's the laziest son of a pineapple you can find.
Yeah, carrots used to be green.
Do you guys finish graphing?
So remember, period is pi over b, so you want pi over 3 over 2, so each period is 2 over 3. Multiply because period is like, you need the half period, so you divide it by half. So it's 2 pi over 6.
Wait, are you?
Half period is this is pi over 3, this is pi over 6.
The original and 3 over 2.
Now you can also have tangent of 3 over 2x plus 1. That means the center is going to go up by 1. That's it. And everything else is the same. So it looks practically the same. It's like that point is going up by 1.
What point do you want?
Huh?
What match do you want?
Okay, so I'm going to show you here. So here is going to be 2 pi, which is pi over 3 over 2, right?
Yeah.
So it'll be 2 pi over 3, right?
Yep.
So that means on the left side, you're going to have a pi over 3. So on the left side, it's going to be pi over 3 here. And on the right side, it's going to be negative pi over 3. And that's going to be asymptote. And I think this one is going to be pi over 6, negative pi over 6. This is pi over 6. Here it's going to give you like this. So this is 3 point here. And that's it.
Wait, Miss Fiona.
Yeah. Now, if I says it's tangent, let me use the tangent of 3 over 2x and then plus 2 like this, then it's going to be 2 points above here. And it's going to be like this. So this is the graph like this. But same graph, but just same graph go up 2 units. Is that point is going up. That center is going up.
Do we have to put 5 or 6? Sorry.
Yeah, why did you put 5 or 6?
You don't have to, but it's really easy to find out that's a quarter period because you can divide it by 2. Pi over 3 divided by 2 is pi over 6. So right in the center is going to be pi over 6. If you don't believe me, plug in pi over 6 here. So it'll be tangent of 3 over 2 times pi over 6. That's equal to 2. And it's pi over 4. Tangent of pi over 4 is 1, so which is 1 here.
So you base it on the 5 or 6, like the dot.
Yeah, so I cut a half to the half. So once I have half pi period here, half period, now halfway of that, that's gonna give you the next coordinates, right? So you basically it's 3 coordinate and 2 asymptotes. So you got 3 coordinate, 2 asymptote, 1 center though. 1 center, 2 coordinate, 2 asymptote. So total 5 points. Still it's quarter period if you really want to go down to it.
Why did you have 2 pi over 3?
What do I what?
Or why didn't you have 2 pi over 3?
Because 2 pi over 3 is from the left negative pi over 3, so the distance from here to here is 2 pi over 3. Because left pi over 3, right pi over 3, so total is 2 pi over 3. Got it?
Okay, I get it.
Now cotangent's easier. I'm sorry, this is a I know for the non-math person it's very boring and stupid.
Are you saying I'm not a math person?
Whoa.
Definitely not.
No, I'm saying people who don't feel like math is interesting.
Yeah, okay. No, I think math is like the worst.
Worse what?
I like doing math when I know how to do it.
I know, I hear that a lot.
But like when I don't, like
You're actually pretty smart. It just
thanks. I'm pretty smart, I guess. What you say something
but what?
You had a button there?
I thought he didn't hear me. He didn't hear me.
He said it in his mind. Watch. No,
I don't remember what I was gonna say. I swear I forgot.
Okay. That's just a little slow.
Hey.
Oh, it's like a song.
Okay, we got 4 minutes left. I want you to graph cotangent of 3 over 4x. Oh, I'm gonna just say plus 4. Let's see. But remember, now you start with the cotangent. Cotangent start with the asymptote. So it's actually easier because you start from one asymptote to the next asymptote. You have a period.
Let's start with
Wait,
that.
what's the plus 4 do?
What'd you say?
What does the plus 4 do? Isn't this still pi over 3?
Yeah.
It's still pi over b. Yeah, cotangent is still pi over b.
You finished that. I am like happy.
Oh, you got You have top one? Two is everyone's like 14. Two is easy.
It's 80 and 3.
Well, in college it's one.
But if you want to help,
Like, yeah, what do they want to do? Be a mathematician.
I need him help on that.
Like,
Which is you gonna convince Krish?
Yeah, it is.
maybe they'll be like computer coders.
What is it?
They'll teach the computer all the math. No?
What do you mean? Coders like one of the
Why do you what?
I have no clue.
Why do you want to college? Like,
Where you gonna study?
wait, this 3, 5, 4, 6, 7. This is
Actually, Chinese. Better than taking all that from. Yeah. They wouldn't do somebody's heart.
Oh, no, that was Lakey tool.
They kill them.
Yeah.
I think drum just got this one's hard.
Right, so tangent, you start here.
Okay, yeah.
Yeah. Forget the plus 4.
So for this one, you start at yeah.
I don't get it.
This
So
is
you're on the right track.
So you.
Okay. You start with the asymptote, but this one is still like what? Pi over
2 over 4.
pi over 3 over 4?
So that's the period.
So 4 pi over 3 is 1 period.
So that's where the next.
My phone, my pencil's died. So what's the period here?
4 pi over 3.
4 pi over 3. So you're gonna go from 0 to 4 pi over 3. And that's gonna be asymptote and asymptote. And in the middle, it's gonna be 2 pi over 3. That's your center. It's gonna go this way.
So why isn't your asymptote 2 pi?
Because the cotangent are different. So pi over 3 over 4, right? So that's gonna be 4 pi over 3, right? So that is equal to periods. So that means you start with the asymptote. You start with the asymptote here, and you got a 1, 2, 3, 4. It's gonna 4 pi over 3. And this point here, this point here, this point here, that's gonna graph like this way. And this is a pi over 3 if you want to know. 2 pi over 3, 3 pi over 3, 4 pi over 3.
So like on this one, your asymptotes were at pi over 3 and your period 2 pi over 3.
Yeah, here is 2 pi over 3. From here to here is 2 pi over 3. But this one, cotangent start with the asymptote. So you start at an asymptote and go into the next period, which is asymptote to asymptote.
So asymptote 0?
Asymptote's at 0, and then go all the way to 4 pi over 3 because that's your period.
So how did you know asymptote is at 0?
Because cotangent always start at the asymptote. You start with the asymptote. You start with the hand, and then you go in whole thing. You start with the end of the hand. It's kind of confusing. It's kind of confusing.
Tangent is here, cotangent is like here. That's 2 over 1 on 10.
So sad.
She said she took point together. I didn't write anything after.
You should.
But you literally told me you shouldn't. Like, you don't have to because you don't have a calculator.
Mr. Yes.
Get a calculator.
69. I do, but I will. But like, didn't he say he's not gonna take points if you don't write the answer at the end?
But that was the end, bro. You did the trick shit, and then you just
Wait, let me
left the
see.
cosine A, cosine